Let's try to understand binary search. Consider this example. In this example, let's consider this is an array, and you need to remember while you are working with binary search, the array needs to be sorted. Either it has to be sorted in ascending order or it has to be sorted in descending order. How binary search exactly works? Let's have a look. Here we are having left pointer, and at the end of the array we are having right pointer. We will find a middle pointer which is equal to the ceil of half of left plus right. Here left is at index 0 and right is at index 6. The ceil of 3 is 3. We can have a middle pointer at this location. Now I'll try to get a target. Let's say if our target is 3, this is target. I need to find whether this is present inside this array or not. Let's see how this can be processed. Initially, I can compare the target with the middle element. As the array is sorted, if the element at this index, that is 7, is greater than 3. So, the scope of finding the element is only on the left side. As on the right side, all the elements are greater than 7, which is also less than 3. There is no point in searching the elements on the right side, and we can search the elements only on the left side. In this case, I'll change the value of r and I'll make it point to m-1. Now, again I'll be calculating the middle, which is left plus right by 2, taking the ceil of it. That is 2 by 2, 1 in this case. Now the middle is pointing to this element. I'll check whether the target is equal to this. Yes, the target is equal. Then I'll try to return its index. If the target is still not equal, if the target is greater than, I'll change the left pointer to m+1, or if the target is less than, then I'll change the right pointer to m-1. You might have figured out the reason why we are trying to do as such. If we come back to the question of complexity, if we just observe, initially the size of array is n. We are trying to reduce it to half. After first iteration, we are trying to reduce that to half, and so on. So, after k steps, the size of array is n by 2 power k. Now, we will stop the process, or we'll stop this iteration when this is the required element, or when it reaches to 1. Whenever we have reduced the size of the array to 1, or whenever we have eliminated all the other options except the required element that has to be searched, then we will stop the process. In that case, n by 2 power k is equal to 1. These are the number of elements. When it become only one element, we'll stop the process after k steps. If you just observe, k in this case can be log n to the base 2. As it includes steps, I am taking ceil of it. So, after log n number of times, or after taking log n steps, I'll try to stop the process of this binary search. If someone asks you what is the complexity of binary search, then it can be log n to the base 2. We have seen about linear and binary search, and that's it for today.